Yeah, good morning. I think today is the fifth class. Okay, we on the last class. I think we are discussing about the some problem, practice problem on so previous classes for logical equivalences, logical implication, and then PDNF, PCNF, DNF, CNF. One more problem. Sometimes the students are asking. I think I will give the homework in the last class. Anyway, I like to do, and then I send it to you. So that's why I can put the snapshot for here. So this is I can how to find out the PDNF and PCNF by using both truth table and without using truth table. Here I can specify by the first thing is truth table. So here the term PQR, there are three inputs. For 2 power 3, 8 input will come. 3 variables, proportion is 3. PQR, that is 2 to the power 3. 2 is fixed to the power number of proportion 2 power 3, so 8 input is there. So that's why the first fold true, fold false, double true, double false, double true, double false, then true false, true false, true false. That is the actual way. Sometimes you can, some of the book they can interchange. This is the exact way. Then I like to go for negation P tends to R, conjunction Q tends to P. This is my question. Okay, I like to go for negation P tends to R. So first of all, I can find out the negation P, the table opposite to the input of P. The negation P tends to R. That is a conditional meaning. If the input is true, the output cannot be false. So true, false, only false. All the other cases are true. So input is true. That is the first term is true, then only you can expect. So first 4 is false. That's why I can put for true. Next, I like to go for true, false. I like to check for negation P to R. True, true. True, false. This is false. Other cases, true, false is false. Then Q tends to be the same one. I can write. Then I like to take the conjunction of these two things. So after min terms indicating for the truth value, max terms indicating for false value. That is a F. So true value I can identify, false value I can put hyphen for min terms, for true value I can put for hyphens for max term. So the min terms, if it is true, we can write P. If it is false, you can write negation. So all the three are true. That's why I can write P conjunction, Q conjunction, all. Suppose if you want to write the max term for this case, you can write true meaning negation, false meaning true. That is a difference. Min terms, that's why I can identify it for here. For min terms, truth value is T. So if P is true, then you can write P. If P is false, you can write negation P. For max terms, if P is true, you can write negation P. If P is false, you can write P. That is the things. I think last class notes you can sometimes you can change. Sometimes I can done some mistakes if you got change it. This is the correct way. So then, so what are the true values? You can write the min terms. What are the false values? Here F I can write P. Here T. That's why I can write negation Q. T negation R. For max term you can write disjunction. For min terms you can write conjunction. So finally you can write these conjunction. You can go for disjunction. Put the disjunction all the 5 combination, that is called the PDNF. D for disjunction. That should be the connectors of the canonical form or some normal form. So this is the PDNF. These 3 things is the PCNF. Totally it should be 8 compulsory will come. Suppose the statement, the question is tautology, all are true, no max terms will come, no PCNF. Suppose it is a contradiction, all are false, no min terms, all are max terms, that is only PCNF, no PDNF. So this is I can done for the without using truth table. So first of all, try to change all the things as a 2 variables, PQ, PR, QR, like etc. That's why I can go for, first I can using conditional as disjunction, double negation law, then I can apply the distributive law. Once again, I can apply the distributive law, and then that is the things. Finally, I can get the 4 terms. So P conjunction negation Q, all conjunction negation Q, P conjunction P, I like idempotent law and the commutative law. So finally, you can here 2 terms, here 2 terms. I think the DNF form is coming. Outside is disjunction, inside is conjunction. So DNF is coming. But canonical form meaning it should be 3 variables must is there. Here the 2 terms, here only single terms, here 2 terms. That's why I want to make this term as 2 terms. I like to use for conjunction true. If PDNF, we can write conjunction true. If we can write PCNF, disjunction false. So question sometimes they can asking PDNF or PCNF, which is your convenient. First you can find out. This question I can able to find out the PDNF first. It is easy. If I like to go for PCNF, some little bit take time. That's why I can find the first PDNF. Then I like to go for PCNF. So this is the two term I want to make. That's why I can write with T. Instead of either you can write Q or R. Whatever you can write. First step you can write Q. Next I can write R. Q and then apply. First T. Negation law or complement law. Q disjunction negation Q. And then I can apply the distributive law. Repetition will come. You can apply the idempotent law. Here two terms are repeated. I can write idempotent law. Then now four terms. Now all the terms are 2. Now I can go the same procedure for here. Conjunction true, conjunction true, conjunction true, conjunction true. So why I can put for true for here meaning? Because I want to introduce P. That's why I can write first step as P. My first T conjunction I can write. And a commutative law will be satisfied. That's why I can put for T here. So missing term is R. That's why I can write R disjunction negation R. True meaning R disjunction negation R. Here T, P is missing. Here Q is R is missing. Here Q is missing. Once you can use the formula for negation law, then apply the distributive law. Then repetition of term you should write once. Then finally I got 5 terms. So this is your PDNF. And then PCNF, the remaining min terms. I think here the truth table, here 5 terms. Remaining terms in case in the place of thus, if I can write the min terms also, these are the 3 min terms. That's why I can write negation yes meaning remaining min terms. This is the meaning. False, that is negation P. True, true. Q conjunction R, disjunction like etc. Then I like to find the PCNF, I can go for duality principle. If it is negation, you can write remove the negation. If it is not negation, you can put the negation and then change conjunction by disjunction, disjunction by conjunction. This is the PCNF. Okay, that is a very most important problem. If anybody got a doubt, PDNF, PCNF. The first of the most important is PDNF, PCNF. And functionally complete set of connectives. Sometimes they can asking in 2 mark or 4 mark subdivision also in part B. So we can expected 1 questions from PDNF and PCNF. Suppose they are asking, normally they can asking without using truth table. They can specify or using loss. The wording is without using truth table or using loss. They won't specify anything. Just to find the PDNF or PCNF, you can go for truth table also is applicable. Here up to this, anybody got a doubt? How to find out the PDNF and PCNF? I think some of them asked the doubt in the WhatsApp also. I can put in that thing. Anybody got a doubt, ma? Students, if anybody got a doubt? Hello? Hello?
No doubt, sir.
Yeah. So I like to move on to the next topic, new topic. So last class also we can discuss the same one. So next we move on to the next topic for here. And then one more thing, when you can submit the homework, try to write your name, roll number section. And some of them you can write uploaded the paper without name like etc. You can try to write name, roll number and your section. Okay, next we move on to the next topic, predicates and quantifiers. So till now proposition, that is a fixed value. Proposition is a fixed value. Fixed statement, a declarative sentence, either it is a true or false, we can say it is a proposition. The predicates meaning is a variable now come inside. Variable, that is an unknown value. Once you can fix the variable, suppose you can give some value to the variable. For example, the first case, x is greater than 3. Suppose I like to put x is equal to 5. Then it is converted into proposition. So predicates is nothing but the variable involving in the statement. A variable involving in the statement, it is called predicates. I think quantifiers meaning normally we can say is a quantity. How much? That is a quantity. So in a predicates, the quantity also included, then it is called the quantifiers. In the predicates, you can fix the value of the variable, then the predicates converted into a proposition. This is the meaning. So predicates is nothing but statement involving variables, such as example, x is greater than 3. x is equal to y plus 3, it is not a proposition, it's a predicate. When it becomes a proposition, once you can fix the value to the variable, then the predicates converted into proposition. Okay, computer X is under attack by an intruder are often found in mathematical assertion in computer program and in the system specification. These statements are neither true nor false. That's why it's a predicate, neither true nor false. We cannot say conclude the result. So until fix the values. So when the values of the variables are not specified, the statement x is greater than 3 has two parts. The first part, the variable x is the subject of the statement. The second part, the predicate, is greater than 3. The symbol specified whether it is greater than or less than, then it is conclusion. So greater than 3. So refer to a property that the subject of the statement can have. We can denote the statement x is greater than 3 by p of x. P of x is a proposition, predicates p of x, where p denotes the predicate is greater than 3 and x is the variable. The statement p of x is also said to be the value of the propositional function p at x. It's not a proposition, it's a propositional function at x. Once a value has been assigned to the variable x, the statement p of x becomes a proposition and has a true value. So until we can fix the value of x, we cannot say whether it is a true or false. If x is greater than 3, if we put x is equal to 5, then the statement is true. Suppose you can put x is equal to 0 or -1, -2 or 1 or 2, the statement is false. So until fix the value of x, we cannot conclude the result whether it is a true or false. So once you know the statement is true or false, you can conclude the result. It is true statement, it is a false statement, that is a proposition. Until that, it is a predicates. That is the difference between predicates and proposition. For example, let the first example I told you, a of x denote the statement computer x is specific. Now the variable first case for here is not a variable, simply it is given a computer x is under attack. The same for here, a computer x is under attack by an intruder. So suppose that of a computer on the campus, only CS2 and Max 1 are currently under, that is the name of the computer, system 1, system 2, are currently under attack by the intruder. What are the truth values of a of, that is the x is a computer is attacked by the intruder. In the place of x, I can give the value, that is a proposition. Predicates, I can convert it into proposition. I can specify the value of x, CS1, that is a system 1, CS2, that is system 2. Now once again, that is system 2. Suppose which is for here, which is the truth value of for here. So for CS1, it is not telling in the above statement. So for that, for CS2 and Max 1 computer only attacked by the intruder. That is a first case is false. Remaining two things are true statement. Yeah, that's all. Similarly, for the next example, the next one you can go for. Let q of x comma y denote the statement x is equal to y plus 3. There are two variables are coming here. X is equal to y plus 3. What are the truth value of the proposition? Proposition abdina you can give, that is a fix the value of x and y. That is the proposition. So for q of 1 comma 2, that is coordinate system x comma y, Cartesian coordinate. Put x is equal to 1, y is equal to 2. You can substitute in the given statement x is equal to y plus 3. You can check whether the statement is satisfied the equality or not. If it is satisfied the equality, then you can say it is a true. If it is not satisfied, that is an inequality, then it is a false. So first statement 1 equal to 5, that is a false statement. Therefore, the truth value is false. Second case 3 comma 0, the truth value is true. That is, there is a n place. For example, this is the 2 place, x comma y, that is a 2 place we can say. In general, the n place predicates, that is a in general n place predicate is a predicate requires n names of objects where n is greater than 0. It is denoted by p of a1, a2. That is here x comma y only 2 predicates. Here n. A1, A2, An are the names of object associated with predicate, and P is a predicate. That is a predicate meaning is a variable x, y, z, x1, x2, x3. That's why I can write a1, a2. Okay. Statement, yeah. Statement function. Please unmute, ma. Please try to mute it. Hello. Hello. Students, please unmute and yeah. Without meaning, you can try to mute. Unmute. Statement function. A simple statement function of one variable is defined to be an expression consisting of a predicate symbol and an individual variable. So, for example, m of x, x is a man, x is a man, or x is a man, x is a woman, like etc. So, m of x, a simple statement function of one variable is defined to be an expression consisting of a predicate symbol and an individual variable. A compound statement. The same compound meaning compound proposition. The same thing for two or three statement. You can using some connectives. Compound knowledge we can using some connectives. Either conjunction or disjunction or conditional, biconditional. Mostly we can using negation. Negation is a input is a unary. So another mostly connecting meaning conjunction, disjunction, conditional, biconditional. Maximum these four only we can use. NAND and NOR we cannot use this for here. We can use only for conjunction, disjunction, conditional, and biconditional. These are things only we can use. So by a compound statement function is obtained by combining one or more simple statement function by logical connectives. Same the statement of the proposition, only the term is converted proposition as predicates. So m of x, x is a man. H of x, x is a moral. So like etc. M and H, that is your that is you can give your own names. M or some other S of x, whatever that thing. That is a connector. And normally comma you can put also it's a and symbol. Comma meaning also and symbol. Like next we come back to quantifiers. A certain declarative sentences involving words that indicate quantity such as all, some, none, one, many, and few, every, like etc. Such words indicate quantity, they are called quantifiers. So in this class all are present. Like you can say all, the symbol is all. Someone is not understood, like etc. That is a someone. Mostly we can using two things, all and someone. That is a everyone and there exists anyone. These are the two things, universal and existential. Like next name is a universal meaning all, existential meaning there is a specific students, like etc. These two things quantity we can use for here, for all and there exists. Mathematically we can use so many definition. Prime number, if P of x is greater than 0 for all x, the for all symbol is a upside down of A. A oda upside down abdimo. That is a for all. There axis is a mirror image of twisted term, mirror image of E. E symbol mirror image reporting, that is called there axis symbol use pannirukkom. So that is for example, some bats cannot fly. Some bats cannot fly, it's okay, it's a simple. Some, the quantity is mentioned, some bats, we will, like this is the example for that. We will focus on two type of quantification, quantifiers or quantification here. Universal, which tells us that a predicate is true for every element under consideration. For all the element, the statement predicate is true. And existential quantification is meaning, which tells us that there is one or more element under consideration for which is a predicate true. That is a specific students, or normally you can write in a class of 50 students, 2 of them today absent. That is the sum of students are absent. That is a sum, either 1 or 2. Some few is a countable numbers. For all, today all are present. So for all, universal quantifiers. Like example, and then note, let us consider for all x p of x. This is a symbol I can told for all. Upside down of A. A symbol upside down for all x p of x. And equivalent to for all x comma x square minus 1, comma meaning and x square minus 1 is the value of p of x. X square minus 1 is equal to x minus 1 into x plus 1. So 1 is the proposition and not a propositional function. It is a proposition, it's not a proportional function. Why? Even though a variable x appears in it, we need not replace x by a number to obtain a statement. The truth value of for all x p of x is to all the case it is true. And x square minus 1, all the case for all x square minus 1 is applicable. X square minus 1 exists. Some value will come, you can put any value of x. Even you can put x equal to 0, minus 5, minus 2, minus 3, 1 by 2. Any value you can substitute. Compulsory, you can get the output. That is a statement. That is a true. If false meaning, it is not applicable. Any other place you can say does not exist. The statement is false. Then only it is false. So this is not a predicate. This is a proposition because you know the output. It is a true. Exactly, you can say it is a true and false. Then it is a predicate. For example, the class also. Your students already informed. Today I am absent, sir. That is a proposition. I know today he is absent. Some oscillation may be present or absent. That is a predicate. We cannot expect. We can predict the value. Once you can conclude the result, then it is called a proposition. Okay. Universal quantifier or universal quantity. So that is the quantifiers for all x. The symbol is for all. This symbol for all x is called the universal quantifier. It is denoted by the symbol for all. We read as for all p of x's, for all x p of x, or for every, for all or for every. Example, let q of x be the statement x is less than 2. Okay. What is the truth value of the quantification for all x q of x? What is the truth value? 3, 4, 5. So the domain consists of all the real numbers. The question is, domain is consist of all the real numbers. They are telling minus 1 by 2, 0.535, but it is not true for all the cases. It is not applicable for all the real numbers. Only it is applicable for less than 2 values. It is applicable. So, for example, give if it is not satisfied, if it is false, you can give only one counter example. I would like to take it as q of 3 is false. You can write q of 5 is false, q of 2.5 is false, like etc. So that for the truth value of this statement is false, because the word is a domain consists of all real numbers. If they can restrict the domain, the statement is true. That is a true word. Existential quantifier. The quantifier for sum is called existential quantifier. It is denoted by the symbol that is a twisted value, that is a right mirror image of E. Mirror image of E. Example, what is the truth value of direct is x p of x? Where p of x is the statement x square greater than 10, and the universe of discourse consists of the positive integer not exceeding 4. Not exceeding 4. But the domain is exceeding 4, meaning up to 4 it is also not true, because up to 3 only it is true. When you can substitute x equal to 4, the answer is 16. X is greater than 10, and before 1, 2, 3 it is not satisfied. The proposition there x is p of x is the same as the disjunction. Disjunction meaning p of 1, disjunction p of 2, disjunction p of 3, disjunction. At least one of the statement is true, the output is true. That is a disjunction. If it is conjunction, all the values are true, the output is true. Here the p of 4 is true, that's why it's a disjunction. Don't bother about the other 3 false statements. Only one statement p of 4 is true. That's why the truth value of the given proposition is true. That is an existential quantifier, universal quantifier. Some example of negation of quantified expression. Suppose if you want to take negation. Negation of universal is existential. Negation of existential is universal. That is, if p of x is the statement x has studied computer programming, then for all x p of x means that every student in the class has studied computer programming. Okay, the negation of this statement is it is not the case that every student in the class has studied computer programming. For equivalently, there is a student in the class who has not studied computer programming, which is denoted by there exists a x negation of p of x for some students. That is, there is a students, there is a some students. That is why I can write there exists a x. Okay, there exists a x negation of p of x. What do you mean by p of x? X has studied computer programming. Upon negation of this, x has not studied the computer programming. So which denote by, so who has not studied computer programming, that is negation of p of x. Thus we see that negation of for all x p of x, every student, that is the first statement, every student in the class has studied computer programming for all x p. I would like to negate the statement negation of for all converted into there exists x, and also bring the negation to the predicates, negation of p of x. So that is the, both of the values are same. Negation of universal quantifier is existential quantifier. Negation of existential quantifier is a universal quantifier. The same things, or similarly, negation x p of x means that there is a student in the class. There is a student in the class who has studied computer programming. The negation of this statement is every student in this class has not studied computer programming. The same of the above statement, which is denoted by for all x p of x. Further, we note that negation for all x p of x is true when there is an x for which p of x is false. In a negation of the statement, the output is true. Once you can take the negate, the statement is false. If the output here the input is false, then the negate the statement is true. That is for p of x is true for every x. Similarly, for you can go for disjunction, either one true, the entire value is true. For conjunction, either one false, the entire statement is false. Free and bound variable. What do you mean by free and bound variables? Once when you can say is a free variable, and what is a bounded variables? Free meaning there is no other restriction for all. There x is not specified. Free, that is a any value. You can give x is any value. X takes any value. That is a free. Bound, some condition. The class timings only the particular session, or the any time, like etc. That is a bounded meaning they have the boundary. They have some boundary, that is called bounded variables. Without boundary, it is called a free variable. The variable is said to be bound if it is concerned with either universal or existential quantifiers. Here we can study only two, universal, existential. The value which not concerned with any quantifier is called the free variables. For example, there x is x. Normally we can write the symbol is this. Sometimes the question paper and computer also typed with the symbol as E symbol for a mirror image. There x is a x, p of x, conjunction q of x. Here x is bound in there x is x, p of x. X is a bound. X is free in q of x. Both are x, but only the first statement is a bounded variable. Second statement is not bounded. Suppose they can using some bracket for here. Both are bounded by the variable. Here there is no other bracket. That's why only x is a bounded variable and q is not a bounded variable. For example, express the statement, some students in this class has visited Mexico, and every student in this class has visited either Canada or Mexico, using the proposition. How to find out for this one? So using predicates and quantifiers. Quantity also, some students, quantity also is there, and variable, students meaning x, that's why is a predicate. So express the statement, some students in this class has visited Mexico. Upon some students in this class, I want to take it as some s of x. X is a students in this class. That's why I can take it as s of x. Students, that's why I can using s symbol. S of x. X is a student in this class. Okay. Visited Mexico. That's why I can take it as some m of x. M of x is a visited Mexico. X is visited Mexico. That's why I can write m of x. Okay. Canada meaning I will like to write c of x. C of x. X is visited Canada. Using this. Yeah, that's why I can write s of x. X is a student in this class. M of x. X has visited Mexico. C of x, X has visited Canada. Okay. First statement is some student in this class has visited Mexico. How we can write the, if a students in this class, some of the students in this class, some will come, you can write conjunction. All will come, we can write conditional. If so, upon some students, their x is a x, suppose s of x, students in this class, okay, and he is visited in the Mexico. Some students, sometimes he is visited in the Mexico. I can write the truth value. Are you in this class? Yeah. If you can section B, then I can write true. If you can write section A, I can write false. Conjunction. Are you visited in the Mexico? Then it is a true. Are visited in the Mexico? It is false. False. You can take the conjunction. Both are if he is not in this class, that is a false. If he is visited Mexico or he is not visited Mexico, either true or false, the output is always false. Only in this class students and he is visited Mexico, the statement is true. That is the, you have to remember the key point. If it is come direct is, you can write conjunction. If it is come for all, you can write conditional. So repeatedly they can asking in 2 mark sums. Repeatedly they can write some statement is given, can write is a symbolic form of this. It's a symbolic form you can convert it into. So next, every student in this class has visited either Canada or Mexico. For all x, every students, for all x, s of x, if x is a student in this class, then he or she is visited Canada or Mexico, or either or. That's why I can write for disjunction symbol, or Mexico, C of x, disjunction M of x. So for all x, S of x tends to C of x, disjunction M of x. Like one more example. Consider these statements of which the first three are premises, and the fourth is a valid conclusion. Sometimes they are giving in the converted into symbolic form. They are telling like that. The word form it is given, I can convert it to symbolic mathematical form. All hummingbirds are richly colored. No large bats live on honey. Bats that do not live on honey and dull in color. Hummingbirds are small. Okay, there are 4 statements. I like to take this first one as P of x. X is a hummingbird. Is a one word is all meanings a quantifier. X is a hummingbird. Which is, X is a large, and then X lives on honey. X is rich colored. These are the key points using this here. P of x, Q of x, R of x, and S of x. Okay, now I can write the statement. All hummingbirds are richly colored. All, for all x. For all will come, already I told you, if it is a for all, you should write conditional. For all, x is a hummingbird, that is a P of x. Then x is richly colored, S of x. Next, no large birds live on honey. No, there exists not. No, or some. No meaning some. Some x, there exists a x. Some birds not live on honey. Some meaning you can write conjunction. All meaning you can write conditional. Some meaning you can write conjunction. Q of x. Q of x is nothing but x is a large one, and R of x. X lives on honey. A large one is not a honey. Okay. Third one, birds that do not live on honey are dull in color. Dull meaning, which color meaning S of x. Dull is a negation that means. That is for all x meaning conditional will come. Negation of R of x. X lives on honey. Here the statement is do not live on honey. That's why I can write negation of R of x. Then if it is do not honey, then it is a dull color. So that's why then negation of S of x. And the last one, hummingbirds are small. They are telling us hummingbirds are small. So upon for all x, all hummingbirds are small. It is specified hummingbirds are small. That is all. Without specifying, you can write take it as all. So for all x, if x is a hummingbird, then it is not large. That is a negation of Q of x. Whatever you can take it as, suppose Q of x is, you can take it as x is small, meaning you can write Q of x, and in this place you can write negation of Q of x. That's how you can. How you can take it as is not a unique way, depending upon your students. Some students are taking as here is giving hummingbirds a small size. That's why I can take it as x is a small. Yeah, I can take it as Q of x, x is small. Then you can statement is here Q of x, here negation of Q of x. That is also acceptable. How you can write for your own way. And also one more way. Predicate formula bound variables and scope free variables. What are the bounded variables? What are the free variables? For the first one, for all x p of x comma y. X is a bounded variable, y is the free variable. Second case, x for all x of both bracket is given. For the both cases, x is given. X for all x is for both cases. So no free variables. Second, the third one, for all x p of x means e of y q of x. So here also for all x, this is not e man, is a there x is y. Symbol is they have done some mistakenly. Is a there x is y. So x also bounded, y also bounded. Bounded meaning either universal quantifier, x is universal, here y is existential. So no free variables. Next one, for all x p of x q of x, disjunction for all y r of y. Here also the both x and y are bounded variables. No free variables. Here there x is a x p of x without bracket, that is a mention. Q of x, that's why I give this example is already given. Q of x is not bounded. So second x is not bounded, first x is bounded. The same one for nested quantifiers. In a quantifiers, you can go for two or more things. Nested quantifiers. Nested quantifiers are propositional functions where one or more quantifiers occurs within the scope of another quantifiers. That is for all x, for all y, x plus y equal to y plus x. There are two things that will come for all x and for all y. For all x and for all y. Like some more example. When more than one quantifiers, order of evaluation is from left to right, because already we can study how to we can preference for the conjunction, disjunction, negation, conditional, biconditional. The order of preference first class I told to you. So that is the first case. We can write first symbol is a negation, then conjunction, then disjunction, conditional, biconditional. This is the order we can study. Same for left to right. Left side to right only you can use for other things. Okay, translate the statement. Every real number except 0 has a multiplicative inverse. You know, multiplicative inverse of the other number. For example, if we can take it as a number as a, then the multiplicative inverse is 1 by a. So the given statement can be written as, for every real number x, we can give the variable. For every real number x, comma, if x is not equal to 0, xy equal to 1. X is not equal to 0, then there x is a real number. Hello? No, it's okay? Yeah. The given statement can be written as every real number x, if x such that xy equal to 1. So the given statement I can write symbolically. But now we can write for all x. Okay, for all x. If then statement, then some y, that is a there x is a y, such that xy equal to 1. Not all y, at least one value should be exist. There x is a y, such that xy equal to. Yeah, once again. Yeah, once again I will check. Yeah, presentation I will check it, ma. Once again. So just I will join. Just for 2 minutes. Okay, I think up to this is a quantifiers, nested quantifiers, like etc. Okay. If you have anybody doubt how to quantifiers, predicates, proportion, like etc. Anybody got a doubt, ma?
No, sir.
Yeah, just I like to check and then I'll okay, on. So the predicate quantifier
Sir, your voice is not
statement.
audible.
Sometimes they can ask 8 mark a simple statement for 2 mark also they can ask me. Sometimes they can ask me for 2 mark also. The simple statement is given. Try. I think subdivision of 4 subdivision it is given. 4 subdivisions also sometimes it is given also. 2 or 1 4 marks also is given, or 8 subdivision like etc. So this is a for symbolic statement. Sometimes asking for 8 marks. Okay, after this you can go to go. Okay, if anybody got a doubt, you can clarify, ma. I think last class we can did for PDF is enough. Today we can predicate and quantifiers. Some more example we can see is the next class, and then we can go for another one is the rules of inference. That is the most important topic and also the last topic of the. And one more topic also is the proof. That is the easy one. So another one more important one, rules of inference topic is most important. Another one is the most important. Okay, ma'am. After this, you can go to go. If anybody has a doubt, okay, if you have a doubt, you can clarify. Otherwise, it's enough. You can stop here, ma'am. If anybody has a doubt, yeah, okay, go. Okay, ma'am. Thank you. Okay, thanks, students. You can go for next session, ma'am. 10:30. Okay, thank you, ma'am. Thank you. Bye.